Good data encryption standard. Now, mm, what is the input block size in DES? What is the input plain text block size in DES? Good, 64 bits. So here we are taking 64-bit input plain text block, and then we are performing the encryption. So in this encryption, what is the first phase? Which operation is performed in first phase in encryption? In DES encryption, we are taking 64 plain text block, and then we are performing encryption process in three phases. In first phase, so we are performing permutation. Okay, so the first step of the encryption in DES is permutation, that is called initial permutation. So we are having we are taking 64-bit blocks, and we are having 2 power 64 possible permutations. So out of this 2 power 64 possible permutations, we are taking one one permutation choice, and then we are transposing the plain text bits, and then after performing initial permutation, and we are going to uh, prepare we are giving these output to round 1. So these 64 bits are divided into two halves, so left half, right half, representing with L and E. Now these 64 bits are divided into two halves and performing the round function. So in round function, we are giving the right 32 bits as input to a function. Okay, so in this DES round function, what is the first step? After performing initial permutation, we are giving the right side 32 bits into function. So in that function, what happened? So the right 32 bits are expanded into how many bits? So 48 bits. So the 32 bits are expanded into 48 bits. That is called expansion permutation by using a table. And then after these 48 bits are given as input to the XR operation. Okay, so along with key. So key also having 48 bits, and expansion permutation result also having 48 bits. So both are XR'd and getting the result 48 bits. So these 48 bits are given as input to the S boxes. So S boxes is also called substitution boxes. Okay, S boxes also called substitution boxes. So these here we are having total 8 S boxes. Each S box takes 6-bit input. So 8 into 6, 48 bits. And then these S boxes convert 48 bits into 32 bits. So here each S box takes 6-bit input and produce 4-bit output. So the representation that will be discussed in last sessions. So these 32 bits are again permutated. So 32 bits are permutated and the result is 32 bits. So the result of the permutated uh, output is XORed with left side 32 bits, and the result of XOR operation is again we are placed at right part of the next round input, and then left part of the next round input is taken from previous round right part 32 bits. So in this way we are having how many number of round functions in DES? How many number of round functions are in DES? So 16. So total we are having 16 round functions, and then after performing 16 round functions, we are performing a swap operation. So in the swap operation, we are placing left 32 bits as right 32 bits as left. That is called swap operation. And then we are performing inverse initial permutation. Okay. After performing swap operation, we are performing inverse initial permutation and then getting the ciphertext. So that is encryption process. So here 19 steps means first step is uh, initial permutation, and then second 16 steps of round functions, total 17, and then swap operation 18, and then inverse initial permutation, that is 19. Okay. After that, uh, decryption is reverse process of encryption, so that follows same as pistol structure, pistol cipher. Now key generation. So in this key generation, we are taking 64-bit input, okay, 64-bit input, and we are removing last column of the input. So this 64-bit input is arranged in 8 by 8 matrix, and then we are eliminating the last column of the matrix. So then we are having 56-bit. So these 56 bits are uh, uh, we are giving these 56 we are giving as input to every round, and these 56 bits are initially permutated by using permutated choice 1. Okay. After performing permutated choice 1, we are dividing these 56 bits into two halves, left half and right half, representing with C and D, and then we are performing circular left shift on both the sides, both the halves. So based on the round number, we are performing 1 bit circular shift or 2 bit circular left shift. Okay. So after performing circular left shift from from the 56 bits, we are selecting 48 bits and giving as key to the XR. And for round 2, again we are performing circular left shift and then taking the 48 bits as subkey. So in this way we are performing left circular shift on two halves, and then we are taking 48 bits. So that is DES encryption algorithm. And after that, uh, you have learned about what is the strength of the DES algorithm, what are the weaknesses of the DES algorithm. Okay. So what are the strength of the DES algorithm? What are the strength of the DES algorithm? So DES having 56-bit key length. So by to perform brute force attack. So the attacker, to perform brute force attack, he will need 2 power 56 possible keys, and uh, to check with 2 power 56 possible keys, it will take more amount of time. So that is the one of the strength. And then it supports avalanche effect. So avalanche effect means when we are replacing the one bit in plain text or cipher text. Okay, so uh, that will affect more number of bits in ciphertext. So, sorry, when we change the one bit in plain text or key, then it will affect the more number of bits in ciphertext. Why that happens means here we are performing multiple round operations, multiple times substitution and permutation. That's why uh, this avalanche effect will occur. So, it is very difficult to cryptanalysis. So, that's why avalanche effect is the one of the strength. And as well as, so remaining strengths are a number of rounds. So here we are performing 16 number of rounds. That is also a strength. And S-box design. So here the S-box design are using uh, GF field. So we are having mathematical fields. So by using GF field, we can construct the S-boxes. The construction of S-boxes are also one of the strength to the DES algorithm. So these are the strengths and weaknesses. So brute force attack is difficult to perform on DES, but cryptanalytics attackers they apply different approaches. So which techniques are applied on DES to find the key? Mm. Which type of techniques applied on the ciphertext and getting the key? Good. Differential cryptanalysis and linear cryptanalysis techniques are applied, and then they find the key. So here linear cryptanalysis will give within the less possible keys, attackers may get the original key. So the number is 2 power 43 possible keys. Within 2 power 43 possible keys, attacker will get the key. So this is about DES, which we have learned in last lecture. So in today's lecture, we are going to discuss about multiple DES and then mode of operations. Now, so PPT is visible to you. PPT is visible. Okay. Section 2. Okay, good. So here you have discussed some cryptanalytic attacks are performed on DES. Okay. So those are differential cryptanalysis and linear cryptanalysis. So to overcome those problems and to give the strength to DES algorithm, they have modified the DES and created multiple DES. So in multiple DES, we are having double DES and triple DES algorithms. So now, so in this session, we are going to discuss about multiple encryptions using DES algorithm, and then uh, we are going to discuss about mode of operations on block ciphers and stream ciphers. Now, so a clearly a replacement for DS was needed. So why? Because Here attackers may applying some cryptanalytic uh, forms, means differential and linear cryptanalysis. So that's why we need another cipher, or we need secure cipher. So here AES is a new cipher alternative. So alternative for DES is a new alternative is AES. So advanced encryption standard. And uh, so the alternative was to use multiple encryptions also is a alternative with DES. So we are already having DES algorithm. So some modifications. So some modifications are specified. So those modifications are applying DES multiple times. So here we are performing encryption multiple times. So that is the modification, and then triple DES. So it is another modification. Okay. So here why the alternative replacement needed? So theoretical attacks can break it. So means differential and linear and exhaustive case search attacks. So these are the another type of attacks. So these are performed by attackers. That's why to provide the security, the alternative algorithms are generated. So in that alternative, new approach is AES. Modified approaches of DES is multiple encryption techniques. Now double DES. So it uses two encryption stages with two keys. Okay. So two encryption stages with two keys. So see the diagram. Here we are taking the plain text P and taking K1 and K2 two different keys and ciphertext C. Okay. Now how we are performing encryption? So initially we are taking plain text and K1. Okay. And we are performing encryption. Then we getting the result X. Okay. So then we getting the result X. So this X and key 2, again we are going to give input to the another encryption second time. So then we are getting ciphertext C. So we can write the mathematical equation like this or like this. So we are taking the plain text along with key and we are performing encryption, and the result is there. So the result along with key 2, again we are performing encryption, then we get the ciphertext. In same way we taking the ciphertext and performing the decryption with K2, we are getting X, and this ciphertext again performing decryption with K1 and getting plain text P. So in this way we are performing encryption multiple times. So for example here DES is the encryption algorithm. So total here we are performing 16 rounds. Okay. And then we are performing swap operation, and then we are performing inverse initial permutation. So after the result is ciphertext. This ciphertext given as input to again DES encryption. Again here we are performing 16 round operations, and then swap operation, and then inverse initial permutation. So the result of inverse initial permutation is ciphertext. So total here we are performing 32 round operations with two different keys. Okay. So this is the double encryption. So now, so what are the problems with the double DES? So the problems are it reduction to single space. So why here we are taking two different keys. Okay. So to decrypt for this approach is comes under cryptanalysis. Okay, so in single DES the cryptanalysis need 2 power 56 possible keys, 2 power 56 possible keys to find the K1. So తర్వాత so to find the K1 key 1, cryptanalysis need 2 power 56 possible keys. Okay, so the length of the key, so the length of the key is 56 bit. So the length of the key is 56 bit, then he need 2 power 56 possible keys. So for finding K1 and the length of the K2, so this length also 2 power 50, this length also 56. Okay, so here also we are having 2 power 56 possible keys. Okay, so then he need 2 power 112. Actually he need 2 power 1, he need to perform, attacker need to perform 2 power 1112 keys of analysis, but so the 56 possible keys are 0000 and so on 0. So all zeros. Next 55 zeros 1. Next 54 zeros 10. Next 54 zeros 11. Next 53 zeros 100. So like that. So you know 0 1 2 3 4 5 6 7 how to represent with to represent 0 we need 56 zeros. To represent 1 we need 55 zeros and 1. To represent 2 we need 54 zeros and 10. So like that finally we getting all ones. Okay, so it represents 0, it represents the value of 2 power 56. All ones means 2 power 56. So from this possible 2 power 56 keys we select one of the key as K1 and another one of the key as K2. So we are taking the both the keys from two these possible 2 power 56. అంటే మనకి టోటల్ 56 బిట్ లెంత్ తీసుకుంటే కీ అనేది, సో K1 ని సెలెక్ట్ చేసుకోవడానికి 2 పవర్ 56 పాసిబుల్ కీస్ ఉన్నాయి. సో K2 ని సెలెక్ట్ చేసుకోవడానికి కూడా ఈ 2 పవర్ 56 పాసిబిలిటీస్ లోనే మనం వేరే కీ సెలెక్ట్ చేసుకుంటున్నాం. బట్ అండ్ K1 ఈస్ నాట్ ఈక్వల్స్ టు K2. ఓకే, K1 అండ్ K2 డిఫరెంట్ గా ఉండాలి. సో అటాకర్ ఏంటి అంటే ఈ 2 పవర్ 56 పాసిబిలిటీస్ లోనే బోత్ K1 ని K2 ని ఫైండ్ అవుట్ చేయగలడు. అండ్ మనం ఇంకొక ఎన్క్రిప్షన్ తీసుకొని ఓకే K3 K1 నాట్ ఈక్వల్స్ టు K2 అండ్ K2 నాట్ ఈక్వల్స్ టు K3 తీసుకుంటే కూడా సో అటాకర్ ఈ 2 పవర్ 56 పాసిబిలిటీస్ లోనే K3 ని కూడా ఫైండ్ అవుట్ చేయగలడు. ఓకే, అంటే మనం ఎన్ని నెంబర్ ఆఫ్ మల్టిపుల్ ఎన్క్రిప్షన్స్ పెర్ఫామ్ చేసినా కానీ అటాకర్ కి విత్ ఇన్ ద ఫీల్డ్ అంటే 2 పవర్ 56 చాయిసెస్ లోనే అన్నిటినీ ఫైండ్ అవుట్ చేయగలడు. సో అందుకే ఇక్కడ ఇష్యూ ఆఫ్ రిడక్షన్ టు సింగిల్ స్టేజ్ అని చెప్పారు. ఓకే, సో నెక్స్ట్ and another problem is here we are having meet in the middle attack. So another type of disadvantage is meet in the middle attack. So it works whenever use a cipher twice. So whenever we are using same cipher 2 times, then it is possible to perform meet in the middle attack by the attacker. So here attacker performs meet in the middle attack. So how? So attacked next with all keys and store. So what your attacker can do means, so this is sender, this is receiver, and attacker is here. Okay, so attacker can choose a plain text block 64-bit. Okay, so for example, networks. So assume this is a 64-bit block networks. Okay, this is a 64-bit block, and attacker don't know the key, but here sender performing double encryption, double DES, receiver performing double DES. So attacker knows that encryption algorithm, that is double DES, but attacker don't know the K1 and K2. So now attacker wants to find the K1 and K2. So 1 minute, uh, I am getting a call. Please wait. So sorry for disturbance. Um, Now, okay. Here attacker takes plain text. He takes his own he takes on his own a plain text block, that is networks, and he don't know the key, but he know the key length, and he know the algorithm. So that is double DES. So I already told that here. So the key 1 and key 2 taken from the uh, 2 power 56 possible keys. Okay. So attacker uh, can perform encryption. Attacker can perform encryption on this plain text by applying 2 power 56 possible keys. So he take first possible key, that is all zeros, and getting the cipher text for the network. So he store the result here. So this is 0. Okay, all zeros means key is 0. So the key is this. The plain text is this. The plain text is this. When we apply all zeros on this plain text to perform encryption, then we get this cipher text. Okay. Now he take 55 zeros and 1. So that is 1. So to apply 1 on this plain text block and perform DES encryption, and he get some another cipher text, and then 2 and applied on this plain text block, perform DES, and he get different cipher text, and so on. He applied 2 power 56 possible keys on this plain text block, and he get the 2 power 56 different cipher texts. Okay, so these values are stored in one table. Okay, so attacker by encrypting plain text with all keys and store in a table. Okay, he stores in a table. Now, so attacker went to sender's system and okay, attacker went to sender's system and same plain text block networks. Okay, so this is networks. So here from this sender system he performed uh, encryption. So encryption means double DES encryption. So but he don't know the key. Okay, so then sender system will generate one ciphertext. Okay, so this is the plain text. After performing double DES here, it will generate ciphertext. So this ciphertext will transfer through network. Okay, he receives that. So attacker receive this ciphertext. So okay, so attacker receive this ciphertext. అర్థమైందండి మీకు ఇక్కడ సెండర్ సిస్టమ్ నుంచి ఓకే, సో సెండర్ సిస్టమ్ నుంచి ప్లెయిన్ టెక్స్ట్ వచ్చేసి నెట్వర్క్. సో ప్లెయిన్ టెక్స్ట్ ని K1 తో ఎన్క్రిప్ట్ చేసినప్పుడు ఎక్స్ అనేది వచ్చింది. సో ఎక్స్ ని అగైన్ K2 తో ఎన్క్రిప్షన్ పెర్ఫామ్ చేసినప్పుడు సి వచ్చింది. సో ఈ సిని ట్రాన్స్మిట్ చేశాడు. సో ట్రాన్స్మిట్ చేసి అగైన్ అటాకర్ సిని రిసీవ్ చేసుకున్నాడు. ఓకే, అటాకర్ సిని రిసీవ్ చేసుకున్నాడు. సో సిని రిసీవ్ చేసుకొని సో రిసీవ్ చేసుకున్న సైఫర్ టెక్స్ట్ మీద అగైన్ డిక్రిప్షన్ పెర్ఫామ్ చేస్తాడు. డిక్రిప్షన్ ఈజ్ నథింగ్ బట్ రివర్స్ ఆఫ్ ఎన్క్రిప్షన్. సో ఇక్కడ అటాకర్ కి కీ తెలియదు. సైఫర్ టెక్స్ట్ ని డిక్రిప్ట్ చేయాలంటే కీ తెలియాలి, బట్ అటాకర్ కి కీ తెలియదు. సో అటాకర్ ఏం చేస్తాడంటే రిసీవ్ చేసుకున్న సైఫర్ టెక్స్ట్ మీద 2 power 56 పాసిబుల్ కీస్ అప్లై చేస్తాడు. సో ఎలా అప్లై చేస్తున్నాడు అనేది మనం ఇక్కడ డిస్కస్ చేసాం. ఓకే, సో 2 power 56 పాసిబుల్ కీస్ అప్లై చేసి సో వాటిని స్టోర్ చేస్తాడు. సో 0 వచ్చినప్పుడు ఏం ప్లెయిన్ టెక్స్ట్ వచ్చింది, 1 వచ్చినప్పుడు ఏం ప్లెయిన్ టెక్స్ట్ వచ్చింది, 2 వచ్చినప్పుడు ఏం ప్లెయిన్ టెక్స్ట్ వచ్చింది, అండ్ సో ఆన్ 2 power 56 వచ్చినప్పుడు ఏం ప్లెయిన్ టెక్స్ట్ వచ్చింది స్టోర్ చేస్తాడు. ఓకే, సో నౌ మీరు ఇక్కడ చూడండి, ప్లెయిన్ టెక్స్ట్ ని ఒక కీతో ఎన్క్రిప్ట్ చేస్తే ఎక్స్ అనేది వచ్చింది అవునా. నెక్స్ట్ సైఫర్ టెక్స్ట్ ని వేరే కీతో డిక్రిప్ట్ చేస్తే ఎక్సే వచ్చింది. ఓకే, అంటే అటాకర్ ఓకే, అటాకర్ ప్లెయిన్ టెక్స్ట్ ని ఎన్క్రిప్ట్ చేసినప్పుడు సో ఇక్కడ డిఫరెంట్ సైఫర్ టెక్స్ట్ వచ్చాయి. సో ఇందులో 0 కీగా తీసుకుంటే ఒక సైఫర్ టెక్స్ట్ వస్తుంది, 1 కీగా తీసుకుంటే ఇంకో సైఫర్ టెక్స్ట్, 2 కీగా తీసుకుంటే ఇంకో సైఫర్ టెక్స్ట్ వస్తుంది. ఓకే, సో అలా డిఫరెంట్ పాసిబుల్ కీస్ ని తీసుకున్నప్పుడు డిఫరెంట్ సైఫర్ టెక్స్ట్ వస్తాయి. అండ్ ఇక్కడ ఈ సైఫర్ టెక్స్ట్ మీద డిఫరెంట్ పాసిబుల్ కీస్ అప్లై చేసినప్పుడు డిఫరెంట్ డేటా వస్తుంది. సో ఇక్కడ వచ్చిన డేటా అండ్ ఇక్కడ వచ్చిన డేటాలో ఒకటి మ్యాచ్ అవుతుంది, ఎందుకంటే ఇక్కడ ఎక్స్ అనేది మ్యాచ్ అవుతుంది కదా. సో ఇక్కడ ఏదో ఒక పాసిబుల్, ఫర్ ఎగ్జాంపుల్ ఇక్కడ 2 అనేది సమ్ నెట్వర్క్ ని సైఫర్ టెక్స్ట్ గా కన్వర్ట్ చేసినప్పుడు సమ్ XYZ అనేది ఇక్కడ వచ్చింది. అంటే 2 అనే పాసిబుల్ కి అప్లై చేసినప్పుడు XYZ వచ్చింది, 1 అనే పాసిబుల్ కి అప్లై చేసినప్పుడు TUV వచ్చింది. ఓకే, సో ఇక్కడ అటాకర్ ఓకే, ఇక్కడ అటాకర్ ఈ టేబుల్లో నెట్వర్క్ ని ఎన్క్రిప్ట్ చేశాడు. ఎన్క్రిప్ట్ చేసినప్పుడు ఫర్ ఎగ్జాంపుల్ 10 అనే పాసిబుల్ కి అప్లై చేసినప్పుడు ఇక్కడ XYZ వస్తుంది. ఓకే, సో ఇక్కడ XYZ రావడానికి 10 అనే కీ యూజ్ చేశాడు అండ్ ఇక్కడ XYZ రావడానికి 2 అనే కీ యూజ్ చేశాడు. సో ఇక్కడ ఇదేంటి అంటే కీ 2, ఇదేంటి అంటే కీ 1. సో అటాకర్ ఫస్ట్ తన సిస్టంలో సో అటాకర్ తన సిస్టంలో ఎన్క్రిప్షన్ పెర్ఫామ్ చేస్తాడు. ఎన్క్రిప్టింగ్ ప్లెయిన్ టెక్స్ట్ విత్ ఆల్ పాసిబుల్ కీస్ అండ్ స్టోర్. సో ఇది ఆ టేబుల్. నెక్స్ట్ డిక్రిప్ట్ సైఫర్ టెక్స్ట్ విత్ కీస్ అండ్ మ్యాచ్ ఎక్స్ వాల్యూ. సో రిసీవ్ చేసుకున్న సైఫర్ టెక్స్ట్ ని డీక్రిప్ట్ చేస్తాడు. డీక్రిప్ట్ చేసి మ్యాచ్ ఎక్స్ వాల్యూ, సో ఎక్స్ వాల్యూతో మ్యాచ్ చేస్తాడు. ఓకే, సో ఎక్కడైతే రెండు టెక్స్ట్స్ సేమ్ ఉంటాయో, సో XYZ సేమ్ ఉంటాయో వాటి కరెస్పాండింగ్ కీస్ ని తీసుకుంటాడు. సో వాటి కరెస్పాండింగ్ కీస్ K1 K2 అవుతాయి. ఓకే, సో ఇలా పెర్ఫామ్ చేయడాన్ని మనం మీట్ ఇన్ ద మిడిల్ అటాక్ అంటున్నాం. సో దానికి పట్టే టైం ఆర్డర్ ఆఫ్ 2 power 56 స్టెప్స్. సో సేమ్ ఎన్క్రిప్షన్ యూస్ చేస్తే మీట్ ఇన్ ద మిడిల్ అటాక్ అనేది అవుతుంది, అండ్ ఇట్ విల్ రిడక్షన్ టు సింగిల్ స్టేజ్. ఓకే, అంటే 2 power 56 లోనే అటాకర్ K1 ని K2 ని కూడా ఫైండ్ అవుట్ చేస్తున్నాడు. సో దిస్ ఈస్ డబుల్ డిఈఎస్ అండ్ ప్రాబ్లమ్స్ విత్ డబుల్ డిఈఎస్. నెక్స్ట్ triple DES. So to overcome the problems in the double DES, here again the DES algorithm is modified with triple DES. So here triple DES are by using 2 keys, and triple DES by using 3 keys. Okay, so here we are performing 3 encryptions with it would seem to need 3 distance keys, but here we can use 2 keys with the sequence of EDE. So encryption, decryption, encryption. So which raises the cost of man in the middle attack to 2 power 1 pulse. So in previously the man in the middle attack it need 2 power 56, order of 2 power 56, but here it need order of 2 power 1 pulse. Okay, so uh, to reduce the number of keys, here we are performing encryption, decryption, encryption, and previously we are performed encryption and encryption. So here we perform encryption, encryption, encryption with different keys. So with different keys K1, K2, K3, then it will be reduced as uh, single stage, means single encryption. So why? Because these 3 different keys are came from 2 power 56 possibilities. So that's why here the sequence is changed. That's why here the sequence is changed. So initially we are performing DES encryption with K1, and then performing DES encryption decryption with K2, and then again we are performing DES encryption with K1. Okay, so this is the mathematical equation, and here K1 and K2 is equal, then it will works as single DES. So why? Because here we are taken K1, okay, key 1, and performed 16 rounds and getting the cipher text. Okay, this cipher text will be decrypted with, if decrypted with again K1, then we getting the plain text P. Okay, if we decrypted with the same key, then we get again plain text. After getting plain text, again we are encrypting with K1, then we get C. So this is single stage. Okay, so if this, then the C value is again A. Why? Here K1 equal to K2. If K1 equal to K2, so encryption and decryption, and again we are getting plain text, again we are performing single encryption. So that's why when we are performing triple DS with 2 keys, we have to check K1 not equals to K2. So this is K2. Okay, so this triple DS technique is standardized in 8732 standards, and then no current known practical attacks are performed, but some theoretical impractical attacks might be become basis of future attacks. So up to now no practical attacks are proved on this triple DES. So this is encryption and decryption. So ciphertext is decrypted with K1, and then encrypted with K2, and then decrypted with K1. So if encryption performed EDE sequence, then decryption performed DED. So here E means encryption, D means decryption. So these are triple DES with two different keys and triple DES with three different keys. So here first we are performing uh, encryption for plain text and key 1. So encryption with key 1 and then again, and here we are getting the ciphertext A. This ciphertext is decrypting with K2 and then getting ciphertext B. This ciphertext again encrypting with K3, K3 and then getting ciphertext C. Okay, this ciphertext, this is the encryption. So decrypt this ciphertext. First we are decrypting with K1. Sorry, first we are decrypting with K3 and then getting B. This ciphertext again encrypt with K2 and then getting A. This ciphertext again decrypt with K1 and getting the plain text. So previously we are used K1 and then K2 and then K1. Here we are used K1, K2, K3, but the sequence is same. So although there is no practical attacks on two-way triple DES, but it is the another alternative approach of triple DES with three keys, and it is adapted by internet applications. So those applications are PGP, S-MIME. So PGP means pretty good parity, and MIME means multi-purpose internet mail extension. Simple internet mail extension, multi-purpose uh, internet mail extension. Okay, so those are the applications which are used triple DES, and then block cipher mode of operations. So up to now, we have seen discussed uh, DES and strength of DES and weaknesses of DES, and then double DES. In double DES, we are performing multiple times encryption with two different keys. So, but the problem is how many times we are performed encryption with different keys. It will be reduced as single stage or single time for the cryptanalysis to find the both keys and meeting the middle attack. After that, we discussed about triple DES with two different keys and three different keys. And then mode of operations. Here we are having five mode of operations has been defined by NIST. Okay, and these five mode of operations are used for implement the block cipher in variety of applications. So those operations, the five mode of operations are ECB, electronic codebook, cipher block chaining, cipher block chaining, and then feedback, cipher feedback mode, output feedback mode, and then counter mode. So these are the five mode of operations. So mainly these mode of operations is used for to apply the block cipher on various applications. So various application need various type of security mechanisms. So these techniques used for enhancing the effect of cryptographic algorithm or adapting the algorithm for an application. So such as applying a block cipher to a sequence of data blocks or data streams. So to strengthen the application, to secure the application, here we are applying mode of operations. So five mode of operations are intended to cover a wide variety of applications of encryption for which a block cipher could be used. So different applications used block ciphers. In those block ciphers, which of the operation we may use, that's specified by these five types of operations. So these modes are intended for use with any symmetric block cipher, including triple DES, AES. So these mode of operations we can apply it on DES encryption algorithm, AES encryption algorithm, and triple DES. Okay. So don't worry, we will discuss these five methods now. So first one is electronic codebook. So here in electronic codebook, we are taking the first initially we are taking plain text. So this is plain text, and then message. This is plain text message. Okay, this message is broken into independent blocks which are encrypted. So we are uh, this message is broken or divided into independent blocks, and each block length is b bits. So if we use DES encryption, then the block size is 64 bit. If we use AES encryption, then the block size is 128 bit. Okay, so here in generally I am telling b bits. Okay, so the original message is broken into equal length of b bits. So if the last block, so if the last block doesn't having b bits, then we are append some bits here. So then the length of the block will become b bits. For example, each block size is 64, then the last block, so if the last block is 30 bits, then we have to append remaining 34 bits. So these remaining 34 bits are zeros. So the appending zeros to the last block is called padding. Okay, so that is called padding. And now here, after breaking the message into independent blocks, we are encrypting each block by block. Okay, we are taking first block encrypted and getting the result, and then we are taking the second block and perform encryption and getting the ciphertext block too. So each block is a value which is substituted like a code book. Okay, so here if first block having computer as a plain text, okay, computer as a plain text, we are performed encryption with the key. Okay, then we got a ciphertext. So ciphertext is, for example, uh, 1234 as a ciphertext. Okay, so this length of this ciphertext also b bits or 64 bits. And then the plain text block 2. So here we are having network. So network as a plain text block, and again we are performing along with the same key and then getting ciphertext block. Here the ciphertext is, for example, 5678. Okay, next we are having security. Okay, we are having security as plain text, and again we are performing encryption along with key. Okay, and we getting ciphertext block. So that is 1526. For example, this is the ciphertext, and here we are having computer again. So again we are having computer again, then we perform encryption with the key, then we get the ciphertext is 1234. Okay, so here if the plain text block having the same sequence of bits in a plain text, okay, if the plain text block having the same sequence of bits in plain text block, then it will produce the same bits of ciphertext. Okay, so here we are having 64 bits, so 64 bits and these 64 bits are same, then here we get 64 bit output, and here also we get 64 bit output, so those both outputs are same. So here uh, each block is a value which is substituted. So these 64 bit values represent the produce these 64. Next, these 64 bit values produce these 64 bit values. So every unique plain text block will produce unique ciphertext block. Okay, if plain text block data are same, then the produced ciphertext blocks data also same. So that is like a code book. So every unique plain text block will produce unique ciphertext block. So each block is encoded independently. So this is the important point here. Each block is encoded independently. So you see uh, electronic codebook example. So initially we divide the message into b bit of b bits of blocks. If the last block is not filled, then we are appending the zeros, and then performing the encryption, getting the ciphertext, and then performing the encryption with key and getting the ciphertext. Okay, so this is encryption. In decryption, we take the ciphertext, decrypt with key, and getting plain text. Taking ciphertext block 2 and decrypt with key and getting plain text. So like this. So this is the simple technique, but the disadvantage is if we are having long length of plain text, then they may be repeated. So here 64 bits, here 64 bits may be same, then here we get the ciphertext same, then the attacker can find the frequency in the data, frequency words in the data, and he may get the key, and he may know the original information based on the repeated words. So that is disadvantage. So that's why this ECB is used for secure transmissions of single values or secure transmission of small values. So advantages. So it is ideal for short amount of data. For example, transmit encrypted keys in AES or DES. For lengthy messages, it is not secure. So why? Because it will produce the same ciphertext for every repetitive plain text blocks. సో ఏవైనా ప్లెయిన్ టెక్స్ట్ బ్లాక్స్ అనేవి రిపీట్ అయితే సైఫర్ టెక్స్ట్ బ్లాక్ కూడా రిపీట్ అవుతుంది. సో దానివల్ల అటాకర్ కొంత ఫ్రీక్వెన్సీ వర్డ్స్ ని ఫైండ్ అవుట్ చేయడానికి ఛాన్స్ ఉంటుంది. సో అది డిసడ్వాంటేజ్. సో అందుకే లెంతీ మెసేజెస్ కి ఎలక్ట్రానిక్ కోడ్ బుక్ యూజ్ చేయము. షార్ట్ మెసేజెస్ కీస్ ని ట్రాన్స్మిట్ చేయడానికి ఎలక్ట్రానిక్ కోడ్ బుక్ ఇస్ ద good method. So this is ECB. So it is a block cipher. And then we are discussed remaining four mode of operations in next session.